Now that we've talked about world growth and population growth as an exponential model, let's switch gears and talk about interest. So talking about the interest that's earned on money. So there's two different equations you have to know or use as far as interest is concerned. First, if you compound a certain number of times a year, you get this equation. A equals P times 1 plus R over N raised to the NT. So this is when you compound annually, so they only actually give you interest once a year. Or if you compound monthly, they only give you interest 12 times a year. The other equation, which is one you've probably seen before, is continuously compounding. And that is when you literally, as soon as you earn 1 penny on that interest, then you are ready to, or they credit it to your account. So it's continuously compounding. Now let's talk about what each of these letters mean. In both of these equations, A is the amount of time, the amount of money at time t. So for example, if we had plugged in 3 for t, saying we want to know how much we'd have in 3 years, A would be how much we'd have in 3 years. Whatever you plug in for t, for time, A gives you the amount you'd have at that time. P, in the real world, that's called the principal. It's the amount of money you put down originally, so it's the initial amount, just like we talked about a couple videos ago. So A is the amount you'll have at time t, P is the initial amount. So A is going to change depending on what you plug in for time. P should not. P is a constant. It's what you started with. Okay? R in both of these equations is the interest rate. Again, make sure you change it to a decimal. So if it's 15%, you write it as 0.15 in your equation. And then t is time, almost always in years when we're talking about interest. And then that covers everything in continuously compounding, but there's one extra letter in the in compoundings per year up top, and that's how many times you compound per year. So that depends on how often you compound. So for example, I've got several down here. If it is annual, then your n is going to be 1 because it means you get paid or you get interest credited to you 1 time per year. Semi-annual, that means twice a year, so n will equal 2. Quarterly means n equals 4 because that's 4 times a year. Monthly is 12, weekly is 52, or daily is 365. So let's look at an example with interest. It says you want to invest $8,000 for 6 years. One account gives 7% compounded monthly. The other pays 6.85% compounded continuously. Which one will earn you more interest? Now you may think one way or the other already, and you may be right, you may be wrong. But we have to check this out because 7% is obviously a higher interest rate, but we only get credited for it 1 time per month. Whereas the 6.85% is a little lower, but we get credited for it continuously. So that means we're earning interest a little faster because we are getting the interest right away, and then then we start to earn interest on our interest. So we're going to have to compare these two. So we've got two different types, so we're going to have two different equations. For the first one, the 7% account, we have to use the equation A equals P times 1 plus R over N raised to the NT. That's the one on the previous slide. The amount, that's what we're looking for. P is our principal, that's our initial amount. Well, that's $8,000. Our interest rate is 7%. Remember, change it to a decimal, 0.07. N is the number of times per year that we actually get interest. Well, it's monthly, so that's going to be 12. So we put 12 in for both ends, and we want to know what happens after 6 years. So we plug in 6 for time. So that'll be our equation for the 7% account. Okay, let's also set up our equation for the 6.85% account. For that one, we're compounding continuously, so we use the Pert equation, as some people call it, P-E raised to the RT. Again, A is what we're looking for. P, the principal, is what we started with. That's $8,000. E is always just E. That's actually a number. It's 2.71. You can check it out in your calculator if you want to. And then our interest rate this time is 6.85. So make sure you put this in a decimal form correctly. It'll be 0.0685. Just move the decimal place over 2. And then our time is also 6 years. So take a second, plug those both in your calculator, and then compare what you get with the two bank accounts. Okay, if you plug that in your calculator, for the first one, the 7% account, you're going to get $12,160.84. So that's pretty cool. You put this money in this bank account for 4 years, and next thing you know, you have, instead of $8,000, you have $12,160. Okay, now if we plug in the other equation into our calculator, we should $12,066.60. So it actually did turn out that the 7% is better, even though it only compounds monthly. The 6.85 is just too much lower for it to matter, or at least over this period of time, to matter that it is compounding continuously. That completes the lesson for the first day. If you need it, the homework is page 383, number 41 through 48. Good luck.